Joe, IDN, back to net.
For the layman, as I am, explain that. Are you talking about bad weather or something interesting to look at?
Something interesting to look at, caused by one of our friends, the sun. The sun threw something very nasty at us, and it hit us yesterday, causing a geomagnetic storm in the magnetic field, knocking the HF bands off, at least according to the ionosomes, and causing aurora borealis to look at, green and red aurora borealis. The atmosphere was very excited yesterday. We may see more tonight. However, the storm has been dropping down in intensity all day long and is now rated as a minimum storm. So I don't know. Give you a idea.
Oh, okay. Yeah, I noticed the HF bands went to, well, I'm not going to say it on the air, went bad about late yesterday afternoon or evening, and this morning they were just dead. So that's what actually happened, huh?
Yes, sir, and those of us who happen to have been looking in the right direction got quite a show yesterday, but among those people it wasn't me, so I missed the show. Green aurora are more common, but at the higher energy levels you get red aurora as well.
Really? That's interesting. That is fascinating to me. Anybody else have any comments about this?
MIC comment.
Go right ahead, Mark. You have the floor.
Oh, just for fun, Joe, Eric and I sat next to each other when we took our technician test all these many decades ago, and we had call signs one letter apart.
Oh, so cool, so cool. I hadn't noticed that. Wow, that's really something. That is so cool. Anything else?
OXS, which portion of the sky was this aurora borealis?
YDN, north. It's always north in the northern hemisphere.
Gotcha, thank you.
AZA.
Right ahead, Ron. You have the floor.
Yeah, I heard about the aurora borealis this morning and was deeply distraught that I missed it. Okay, not deeply. But my question was, is there a specific time of night that's better than others, or is it just catch as catch can?
I would have guessed later in the night would have been better, but I'm looking at the ham clock aurora map right now, and it looks like early evening, probably 1 or 2 hours from now, will be the best shot at it. We'll see. The pictures I saw yesterday were dated 7 p.m.
Yeah, okay. Well, thank you very much, K0AZA.
K0YDM.
YDM, go ahead.
Just ending the exchange.
Oh, okay. Anybody else have any comments about this? Please call.
CWM, Joe.
Have the floor, my young friend.
Oh, thank you. Yeah, I want to I really appreciate the information on the aurora. I've only seen that one time before in my life in Fort Collins. So, boy, I'll be looking up there tonight. Look up. And when I checked in, I tried to get quick on the key and not double, triple, quadruple there. And I wanted to say that you're the best, Joe. You're the best director there ever was. Thank you very much. K0CWM.
Well, thank you, my friend. I do appreciate that. I've done a few of these, so I kind of remember some things. But like I've always said, if you're in amateur radio, you're in for fun. So let's have a good time with this. Any other comments? Okay, does anybody have any questions or any type of topic you'd like to bring up? Well, call now.
LAI.
Chad, you have the floor.
Yeah, Chad here. Sorry. Okay. I have a question. I've got an amplifier, and I changed it from 115 to 240. And the 12-volt supply in there changed to 16.75. My 240 supply is actually 249. And I've got it set for 245. I was wondering the impact of changing that to 240.
Mark, that seems like that could be right up your alley.
Double with the Joe, go again.
I was saying that anybody else got a comment? Go ahead.
NYY. If your filament voltage is too high and you set your primary voltage to a lower voltage, your filament voltage will go even higher. If you have a 250 volt setting on your transformer, that would bring your filament voltage back down in line. And 0 NYY.
Roger that, the 0 LEI. Thanks. Yeah, I was wondering, I was going to move it one way or the other, but I wasn't sure which way to go. And so I'll move that up to 250. Thank you.
Any other questions? Call now.
MLG.
Go ahead.
I just got a confirmation on a date that will or won't work. As many of you know, well, not so much me, but Greg and Bob and Bart and all kinds of invest testing. And we have a marathon approaching first weekend of May, and I'm intending to use HF for the stations farther up in the canyon that repeaters are not able to cover. And there's going to be an Invis field day at my place where probably going to be March 25th, right? March 25th is about a 99% go, weather permitting. So we'll have several different configurations of antennas at my place. I'm going to have people at the finish line for the Colorado Marathon, which is downtown, the Equinox Marathon, which is just west of Ted's place on Highway 14. If anybody wants to join in and learn, bring your knowledge, ideas, whatever, it's going to be an early morning event. Probably about 04:30 at my place, and then all the other stations involved. The canyon stations will, whoever does that's definitely going to have to get up early, but the communications for the marathons start early in the morning. So we want to start testing early in the morning. I have found out that 60 meters, those first 3 channels, some of you may or may not know, but 60 meters is 5 basically channels that you can talk on. And the first 3, 1, 2, and 3, are busy every day. There's nets on those every day. I didn't realize that. So 60 meters is out, right? So I'll hang around after net for a bit if anybody's interested. K0MLG is my call, and my email address is also good on QRZ, or I can give it to you now. It's my old call sign, Kilo Charlie 0 Quebec Oscar Kilo @gmail. Many of you are already on the email list because you've helped with marathons in the past. So, but if you're not sure if you're going to be on that email or you want to be added to it, let me know, either right after net or shoot me an email. That's all I have for the net tonight. K0MLG, back to net.
Any questions, Marty? Okay, anybody else have any questions or comments? Go ahead. I have kind of an interesting thing that I've been kind of reading about. Maybe, Mark, you can tell me this. Generally, when you set up a vertical antenna, you always need some sort of counterpoise. Well, I've read somewhere that they say it even does help horizontally polarized antennas. Anybody ever tried that or know anything about that?
YDN?
YDF?
Well, I want to clarify your question. Are you suggesting that conductive wires underneath for example, a dipole would help? That is the case, and I can go into more detail.
Yeah, that's exactly what I'm looking at.
Yeah, I had the privilege of having access for a short period of time to a radio test zone called Table Mountain, just north of Boulder, and it had all sorts of interesting things on it. And it was a government facility, which meant when they tested something, they spared no expense. So one of the things they tried is they had these two towers set up for hoisting up dipoles, and on the ground, well, in the ground by the time I saw it, there was this brass mesh welded together covering the ground all the way around the dipole. And I believe that conductive ground is generally good for a lot of antenna designs. There are counterexamples, though. Counterexample would be the beverage. The beverage does not need conductive ground. In fact, it works best over poorly conductive ground, because how it works is the speed of radio waves through poorly conductive ground versus the speed of radio waves through the wire above or on the poorly conductive ground.
That's interesting. Anybody else care to comment on this?
If you lay down a mesh of brass underneath your dipoles, feel free to do that. That would not hurt at all. This is KB0YDM. Back to that.
Yeah, but does it help any? I mean, what I'm seeing is that it can lower SWRs. I've got a hex beam up here, which is all horizontal. I'm not dang sure. I mean, it's sitting up 30 feet. I'm not going to put anything underneath it. But if you had, like you said, a dipole, or even a dipole with ham sticks, where you put two of them on and this and that, and you actually run it horizontally polarized, would that make a difference then?
I believe the answer is yes. If anybody knows differently, or if I don't know what I'm talking about, please call me out on it now.
MIC.
Go ahead, Mark.
Well, there are three areas of discussion. The first, I agree categorically. Yes, if you put a conductive mesh underneath a dipole, it works better. Joe, what's happening there is you're decreasing ground loss, because, of course, a horizontal dipole is radiating in all directions, up, down, left, right, etc. And the down portion of the radiation is going into the dirt and warming up those chilly little earthworms. If you put a mesh down, you are shielding the ground and causing more of that radiated electrical energy to go up and out. The second is you're trying to build a two-element Yagi. This is what I know W0LEV does to look at Jupiter. You put a dipole up and you put another wire underneath it, sized longer than the dipole, so it's a Yagi reflector. So you have a driven element, that's the dipole up in the air, and you have a reflector element, that's the longer wire down on the ground. The third one that I'm aware of is putting a backer wire underneath an NVIS antenna, and we'll get Greg to chime in. As Greg has found, the optimum height for an NVIS antenna is 0.2 wavelengths, but as far as I have read, you are still putting significant amounts of energy into the ground, thus lower than 0.2 wavelengths is much more lossy. And you do indeed benefit from a wire or a mesh, if you can afford it, underneath an NVIS antenna to, once again, shield the ground and cause more of the energy to go up. Back to net.
NCOEMP, would you care to comment?
Yeah, Joe, I haven't directly experimented very much with reflectors on the ground below NVIS antennas, but from what I have done and from what I've read, over good ground, very good conductive wet ground, it won't make a big difference, but we usually don't have that. We usually have something less than good ground, and in that case you'll get improvement. The other thing you'll get is more consistent performance, because if you don't have those reflecting wires, and it can be more than one. I've seen people that use 7 wires underneath their dipole. So it can be more than one wire on the ground, or it can be a whole field of chicken wire laid out on the ground. But as the ground conditions change, if you don't have any wires on the ground, as ground conditions change throughout the year between dry and wet and snowy and frozen, your performance will change. And if you have a good ground reflecting screen set up, it minimizes that effect and zero EMP.
In agreement with all of that, several of the NVIS antenna designs I looked at use reflectors in the ground. All the ones I looked at, I only looked at a couple different designs. I have, for example, a 40-meter NVIS. The one I used first was 5 feet off the ground, and it had a 10% long reflector centered under the dipole and another 6 feet to either side of the dipole. And the commentary on that antenna design was that these antennas work a little better or a little worse depending on your ground conditions, but you put the 3 reflectors down, you get more energy reflected upward, and the conditions of the ground have far less effect on the antenna and its performance. So another 2 cents, kind of in agreeing with Greg and Mark and our test experience. The only counter to that, let me grab a nickel. When I set up the Thompson Canyon, and Greg was up the Pooter Canyon, and Mark was in Loveland, and people were in Fort Collins and other places, when Kyle and I removed my ground wires, I had the same exact setup up the canyon there. When we removed the ground wires, things seemed to improve slightly, but we also noticed on the subsequent occasions that at that time of day, propagation improved as well. So I don't know how good that ground was underneath my antenna, but when we collected the ground radials or the ground reflectors, things were better. That doesn't mean they weren't helping. Again, we suspect it may have also been conditions. So there's some determinate information and some indeterminate information. N0 and YY back to that.
Any other comments before I go to phase 2 here? Okay, phase 2. I've asked this question and no one seems to be able to answer it. This is a good place. Can you use a ham stick horizontally polarized in NVIS?
Yes.
Okay, what do you have to do special on it?
Well, it needs to be working against something, so you probably want another ham stick pointing the other way, and you feed them in the middle. So you'd have 2 ham sticks set up as a dipole. And you don't want it any higher than 0.2 wavelengths above the ground, or 0.25 wavelengths above the ground for whatever band you're setting it up on.
0.25 is a good, that's cool. Okay, so that's the key to all this stuff, is how high you actually have it, correct?
0.2 to 0.25 wavelengths is optimal, but you're going to be on 80, 60, or 40 meters. So on 80 meters and 0.25 wavelengths, you're going to be over 60 feet above the ground. That's difficult. In reality, if you go down to 15 feet, which is much lower, you do not lose a lot of performance, and it's a lot easier to set up. So I work 15 feet at home on all 3 bands, 15 feet above the ground. When I set up in the field, I work at least 9 feet above the ground, because that's high enough that people won't touch the wire unless they really try to. And I'm still getting good performance at 9 feet. But 15 feet, if you can do it, just don't go above a quarter wavelength. Don't go above that point for any reason if you're trying to do NVIS. And 0 EMP.
And you're working 15 feet or 9 feet, whichever. You're working all 3 bands with that?
Yes.
Wow, that's a lot of information. I appreciate that. Anybody else care to comment?
CWM.
Go ahead, CWM.
Say, Greg, with that information, your grounding image of, say, a steel building to the ground or a mast that requires some chicken wire or whatever else in the dirt, what's that influence in height?
So if you're doing NVIS, you're using a horizontally polarized antenna a quarter wavelength above the ground or lower, and you want your RF going pretty much straight up. So ground reflection helps get all of your RF going straight up. And I don't use chicken wire or wires on the ground. I do not. I've experimented with a little bit in the past, but when I deploy, I do not do that. However, it could help some. Especially, it will help more if you're on lousy ground. Very dry, absorbent, RF absorbent ground. It would help more to have reflectors on the ground than if you're over good wet ground or over water and zero EMP.
Thanks, Greg. Okay, very good. I'm just curious because my antennas are placed on top of a steel building. So just wondered what the difference is from earthing ground or an influence from a steel building. But thank you. Copy that. K0CWM.
Jay, that was an excellent question. I was thinking of it when you were saying it. That's very good. I thank you very much for that. The chicken wire versus just a straight wire out there, is it about the same, or is one better than the other?
Well, if you want to get into relatively what's better or not, if you want really good, put a dipole up 0.2 wavelengths above the ground, so about 60 feet on 80 meters. And then cover the ground in all directions for several wavelengths with wire, or chicken wire, or mesh. So probably, I don't know, a quarter mile in every direction. That's going to give you your best performance. It's going to be extremely expensive and impractical to do. Then you start compromising. You start having an antenna lower to the ground. You start having less reflective material on the ground, or none at all, which is what I do. But one wire underneath might help. 3 wires might help a little more. 7 wires might help more than that. Laying out a field of chicken wire on the ground, 20 feet wide, and a little bit longer than the dipole would help even more. So, but how much it helps and if it's worth it or not, I don't know. And it's going to depend partly on the ground.
YDM?
Go ahead, YDM.
Out at Table Mountain, their facilities, they did they overkilled it. Basically, they did brass mesh in every direction for hundreds of feet. I don't know how many hundreds of feet. It wasn't a huge area, but it was big enough. It was bigger than a couple of acres. So make of that what you will. Hippie Joe YDM, back to that.
What I make of that is hundreds of feet of brass. It must have cost them a fortune.
Go big or go home, and somebody double.
If I double, will somebody come back?
This is BNK with a question.
Right ahead.
N0BNK. Well, I know with dipole, they're kind of directional off the broadside. When you go inverted V, they're more omni. So, doing NVIS with a dipole, does the orientation north, south, east, west, or anywhere in the middle make a difference? And also with just a long wire, with the balun on it, does the orientation really make a difference when you're doing NVIS?
EMP.
Go ahead, Greg.
So, since we're reflecting off the ionosphere for NVIS, that makes the return signal coming down more circularly polarized or elliptically polarized, so it's kind of turning when it comes back down anyway. So for that reason, like if your antenna's running north-south and your buddy's 20 miles away, does it have to run the same direction? No, it doesn't. So for that reason, no, it doesn't matter. One thing I found setting up in the canyons is sometimes power lines overhead, power lines and telephone lines carry noise, and it's better to set up away from power lines. But if you can't, if you have to set up near them or even underneath them, and there's noise on the power lines, it's best to run perpendicular to the power line if you can, because that'll minimize noise pickup from the power lines.
In YY?
You have the floor, Bart.
In my early readings on NVIS, and I specify that because I don't have test data myself, but the comment was made several times that the directionality of a dipole is almost irrelevant when you're close to the ground doing NVIS. I have also been told that any reflected signal, including the signals reflected off the ground back up, are essentially random in their polarization. And they certainly are when they reflect back down from the ionosphere, as Greg said. But the comment was, the question specifically was the orientation of the dipole, and the readings I saw told me that it is dramatically reduced, if non-existent, in terms of any directionality when you're that close to the ground, which is why for long-distance stuff, you don't want them close to the ground. 0NYY back to net.
I guess what you're saying is it becomes omnidirectional at that point. It's not really, it's horizontally polarized, agreed, but it's not directional, correct?
That is correct.
That is fascinating. I did not know that. There's a lot of stuff I don't know, by the way, guys. But that is something that's fascinating. Anybody else have any comments?
Go out and play, Joe. You should go with us.
I'm more than welcome to. I'd sure like to. I'm a little busy, as you know, but I can always spare time for you guys.
I was going to say, Joe, you got to come up when we have the test field day on the 25th.
4 o'clock in the morning? You got to be out of your mind. My dogs don't even get up that early.
Well, we're going to be playing till about probably 09 or 10, but so we wouldn't have to be quite that early.
Okay, I'll see what I can do. That does sound like fun. Yeah, I'm just learning this too, and with Aries we're now getting into the point, and I'm not going to get into all the technical stuff that we're doing, but we've got certain areas that is going to have to do that. Greg was nice enough to come in on one of our district meetings, and I think he's got these guys fired up, so I need to learn really quick. Any other comments, questions?
And one for Greg.
I think you were first, Marty. Go ahead.
Okay. So, Greg, I've got to refresh your memory, and for those that don't know, my 84-foot wire goes into a 9-to-1 /transformer, and it's about 12 feet off the ground, which is AGL in ham speak, above ground level. It's around 12. And my orientation, you just said it doesn't matter, but north, east to southwest. Now Justin, on the northwest side of Loveland, he had a little bit longer wire, and he reconfigured to, not sure exactly what length. I was hoping he'd be on tonight. It's not quite 84. It's the, I think 70. What's the next number down? 71 or 2, whatever it is. But he's got an L in it to fit it in his yard, and he's about the same height or so, close to it. On the WebS, so he and I couldn't hear each other very well today. Now, I've got a noise floor, and so does he, but going to the WebSDR in Utah, I was 9+. I mean, it was just right over there in the cherry patch. And he was only about an F7. So we're trying to figure out what's changed. Both same power output, same same length counterpoise, but something's just not quite right. We can't put our finger on it. You're probably going to need more information than that, but have any ideas why his signal isn't near as good as mine?
Let me make sure I got this. So there's not a huge difference between S7 and S9 to begin with, and you're coming from slightly different areas. The path could have been a little different. If he has a bend in his, you said he had an L shape to his wire. I imagine that's as viewed from above, it has a bend in it. That might not be helping him a lot. You guys are certainly both over different kinds of ground, so that could be a big factor. If he's on a city lot, I don't know exactly what his layout is, but if he's on a city lot, there could be other stuff around, overhead wires and reflectors and things that could be impeding his getting a signal launched. So could be a few things.
Okay. Well, we're going to address that. He's going to shorten that wire. He's going to, just fold some, I think 12 or 14 feet, fold it back and tape it up, shorten it up a little bit, and take that L out of there. We've always said that it doesn't matter really that much, but maybe it does. We don't know. All right, that's all I had. K0MLG.
Bart, I think you were in there. Go ahead.
I was, Joe. I sympathize with your issue of getting up at 4 o'clock in the morning to go help with the testing, but it's important that you do so. But the option is you don't have to get up at 4 o'clock in the morning. Just stay up all night and come out when we're ready to go.
I've played in too many bands till 2 or 3 o'clock in the morning. I think I'm retired, but I will definitely try to be there in the morning sometime. But it ain't gonna be no 4 o'clock.
Just trying to make sure you know what your options are that are available.
I do. Any other comments or questions except me getting up at 4 o'clock?
One more thing. I do have facilities out here that have running water in the bathroom in the shop, so plenty of places to park. So it should be a fun time. K0MLG.
Double with Marty. Come back.
Alpha 0, Bravo Foxtrot Delta, Jerry, Loveland, Colorado, late check-in, and I have a question.
Go right ahead, Jerry.
Okay, so I've been monitoring this and then kind of reading the mail there, and somebody said they had a hex beam antenna. I'd like to know more about that because I'm thinking about buying a Buddy hex pole antenna because I live at Good Samaritan and they have to take it up and put it up and take it down all the time. Over.
I don't know much about the Buddy ones. I've got a full one. I've had it up there for 6-7 years, I think now. And I really like it. I mean, it's my go-to antennas. It does 20 through 6, and it's a full. It's I think 20 feet wide when it's up there, if I remember right. No, that can't be right. Maybe it's 15 feet wide. They are absolutely dynamite, but they aren't cheap. Which one are you looking at?
The Buddy Hex. I think they want $700 for the antenna, and another $700 for the tower to put it on, which would be about 38 feet.
Mine's not up that quite far. I'm only up probably 20, 25 feet, I guess. And Greg can tell you more. He can look at. He's been up there. But you do need a rotor with it too. Does that include the rotor?
No, I don't think it does include the rotor. I'd probably have to build some type of rotor to rotate it. I'm not sure.
Yeah. I tell you, we can get hold of Radio Dan. He always has a used one laying around there or something, and he does really good deals on the thing. I have to admit, he's got me a. It's not a tail twister, but it's a high gain thing. I've had it for quite a while, but it is a directional antenna now, and it's pointed one way or another, and it will only go one way or another. You can hear pretty much any place, but you cannot transmit unless you have that thing pointed that right direction.
Roger that. You got a call sign for Radio Dan or a phone number?
W7RF is his call sign, but you can actually just go on Google and just type in Radio Dan, and he's there. He lives right between Lebanon and Fort Collins. In fact, kind of out where you're at, I think.
So that, thank you. This is WA0BFD, Boulder Fire Department, or Bravo Foxtrot Delta, however you want to go.
That's fine. Yeah, Dan's a really good guy to work with. I've never sold anything to him, but I've bought a few things, and he's always fair. I've always thought he's really a great guy to work with, and he's smart. I tell you what, he really knows what he's talking about, and he'll give you the best deal he possibly can.
Okay, roger that. Thank you for the comment, and I'll check with the Radio Dan, and I'll just Google him, I guess. This is WA0BFD, back to net control.
Yeah, I really like the hex beam. In fact, I would not. James and I talked years ago about this, and there was a guy in this is a full-size one. There was a guy in Florida that was making them, and James went down there and talked to him at one of the events, and he said, "This is the one you got to buy." And I tell you what, it took 20 minutes to set this thing up. Now, it took us about 4 hours to get it up in the air, but it was so simple to put together. Everything was cut to length. You didn't have to tune anything. And the worst case I've got is 1 to 3. That's the worst on any band. I use a tuner because I've got a 680 out there that does 80 meters and of course down to 6. And it's omnidirectional. But the only reason I've got it out there is because it does 80. But and 40, but I really like it. Any other comments or questions?
W1VAM.
Ivan, you got something you'd like to talk about?
The WWV Amateur Radio Club here is offering tours of WWV and also NIST up in Boulder on Friday if anybody's interested. Look up the www.arc.org website to sign up.
Thank you for that. I was going to mention that. I'm glad you did. They're also doing their celebration on Saturday from 10 to 3. It's at the Fort Collins something. I can't remember what it is. Do you have any information on that?
On Thursday evening, 7, I believe, till 9 o'clock, they're doing a couple of presentations at the Discovery Center. And also on Saturday, we're setting up a couple of HF radios there and operating from the Discovery Center.
Yeah, NCARC's going to be there, Aries is going to be there, and some other people too, so stop on in. Any other comments, questions? Well, I'd like to thank everybody. This has been a very interesting night. I do appreciate it, and kind of like Kyle didn't make it, I had the opportunity to do this. I thank you so much for joining us tonight. Remember, Wednesday night we have our regular net, our club net, and then Thursday night's Aries net. So if there's nothing else, this cadence at KYU clear, and anybody, the repeaters open for general use, everybody have a pleasant week, and let's hope stay out of the snow.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. For more information, visit our website, ncarc.net. Thanks for watching, and don't forget to like and subscribe.